So lesson B, we are reviewing some more geometry topics. I think I just clicked on the wrong folder there for previously. So get out those formula pages and your notebooks, and we'll start with some vocabulary. And first off, perimeter is how far is it around some two-dimensional shape. So if I talk about something that is 3D, like this box, I can't talk about perimeter of the whole box. I could pick any one of the sides. So in this case, maybe the bottom rectangle, and I could take the perimeter of how far it is around the outside of just that one side. So perimeter is for a 2D shape. Area is how many squares does it take to cover that 2D shape. So the hallway is a good example. I think those tiles are each 12 inches by 12 inches. So each tile is 1 square foot. So if we counted up how many tiles out there in this part of the hallway, we'd have the area of that part of the floor. Now, sometimes we'd have tiles where it's up against the wall and a full one didn't fit exactly. So there's a half tile there. So we put this half plus that half and count those together as 1 square foot. Or if I had a third of a tile here and a third of a tile here together, that would be 2/3 of a square tile. I'd have to fill in all the little spaces with that. Surface area, we take a solid and we add together the area of all of the different surfaces. So if I wanted the surface area of this cone, I'd need the surface area, I need the area of the circle, and I would need the area of this slanty, curvy part that goes around the sides. And I'd add those together for the total surface area. If I wanted lateral surface area, I would not include the base or bases. So for this cone, I would not include the circle. The lateral surface area would be just the curvy, slanty part. So you can kind of look at this one and you see they didn't stain the bottom of it. They were just figuring out how much stain would it take to cover the exposed sides of it. If you're painting a house or a classroom, you generally don't paint the floor or the ceiling. Those are the bases of the room. You just want the area of the walls for how much paint you need to buy. Volume is how many cubes would it take to fill something up. So if I wanted the volume of this box again, maybe I have, I don't know, sugar cubes. I think they're about 1 centimeter cubed. So I'd see how many whole ones I could fit in real tightly and count those up. But then around the edges, I'd have to crumble some of those sugar cubes into grains of sugar to dribble into the spaces that weren't yet filled. And the total would be how many sugar cubes did I use, crumbled or not, to fill up the whole thing. Same thing for the cone. I'd really have a lot with all those curves to fill in with grains of sugar. Trying to talk enough that you have time to get these copied down while I'm talking. Are we okay to go to the next slide? Okay, moving on to some formulas. Who remembers for me the formula for the area of a triangle? Jace? Either base times height divided by 2 or 1/2 base times height. Know it both ways and use whichever one's going to make the work the easiest for that problem. For me, especially if I have an even number for my base or my height, let's suppose my base is 5 and my height is 16. If I do base times height divided by 2, that's really easy to say, oh, that's just 5 times 8. However, if I have some fractions thrown in there, let's suppose my base is 3 1/2, so 7/2. And maybe my height is 1 2/3, so 5/3. That would be base times height. And then if I do divided by 2, I kind of get confused if I can't punch it in on a calculator, and sometimes I enter it or I do it not quite right and don't get the right answer. I am less likely to make a mistake on one like that if I just do a half base times height. Then it's pretty easy for me to see, multiply across the top, I have 35, and across the bottom, I have 12. It's not a very nice fraction. Maybe I change it to a mixed number instead, but that's easier than the complex fraction of fractions inside of fractions. So be smart as you do these. Do what's going to work the best for you. Who remembers isosceles, equilateral, and we'll go ahead and throw in scaling, even though it's not officially on the list? Who remembers anything about which one of those is which? Riley? Have sides that are all the same, and then what does that mean also has to be true about the angles? They're also all the same, and 60 degrees. So what about isosceles? Anybody remember that one? Alex? Mm-hmm. Well, so two sides are the same. Go across from those two sides. Those angles are the same. Top angle, bottom side, or whichever way it might be turned, are different. Equilateral, three congruent sides. All three angles are 60 degrees. And we'll get to it maybe Friday or something, but scaling, all are different. Three different angles, three different sides. Everybody shout out, what do the angles in a triangle always add up to? Perfect. And that is triangle sum, so we abbreviate that TS. And as soon as it looks like we all have that copied, we will continue to a few more. Almost there. Have enough down that it's okay for me to go on, or wave if you need me to wait. All right, I don't see any hands going up. Let's talk about circles next. So let's begin with the circumference of a circle. First off, who can tell me what in the world we're talking about when we talk about a circumference? And then we'll talk about the formula for it. But what's the idea of a circumference? What is it, Alex? Yep, it's the perimeter. It is how far, if we go all the way around the edge of the circle. If we need to take a piece of string and put it along there, how long would the total piece of string have to be? And the formula, should have asked you, but two ways of thinking of it, either pi d or 2 pi r, because 2 times r, 2 times the radius, is the diameter. So if they give you the diameter, use pi d. If they give you the circumference and ask you to find the radius, do 2 pi r. Whichever one they give you or ask you for, use that formula. We're going to get to that, and no, we are not. It has to be pi button, but we will get to that. I've got a whole slide in a moment that talks about that. But thanks for thinking ahead to that. Okay, arc length is when we talk about part of a circumference. So it is a fraction of the circumference. So maybe I just want to know that part of the circumference. In math, when we have the word of, it usually means times. So fraction of circumference means fraction times circumference formula. So the formula for arc length is going to be x out of 360. So we know that we're just looking at the x degree part of it, but the whole circle is 360, so that's the fraction. And then either times pi d or times 2 pi r, whichever one you want to plug in there. Who remembers area formula for a circle? Anybody who hasn't answered yet who'd like a turn? I will eventually start picking on everybody. But even if you don't know it, that's okay, because we work together to come up with the answers. Area of a circle, hoping there are more than a couple people who think you remember it. You used it a lot in the past. Emily? Perfect. It is indeed pi r squared. Area is in square units. The area formula is the one that has the square in it. So that would be if I wanted to cover the whole thing with tile or with paint, how much would it take to cover the whole thing? A sector is a fraction of the area. So if I go back to my picture, it would be, if I just wanted to paint in that part, how much paint would it take? So fraction of the area is going to be fraction times the area formula. So just like we had before, x over 360 for the fraction, times, in this case, our formula is pi r squared. And then next, we're going to answer that question about the 3.14. And if you have your own calculator, pull it out. Those that didn't, I think, already grabbed one from up here. Alex? We will always reduce it. We'll start out with that, and then we'll show reducing it to whatever we get. But I'll model that with a couple of examples we're going to do in just a moment. All right, so everybody have your calculators out. And let's talk about at Devlin what we do with pi. Any problem that has pi in it, we need two answers. All of the numbers except for pi have to be reduced as much as possible, not just punched into a calculator. So if there's a fraction in front of the pi, you have to simplify that fraction and write that times pi, and then you can put it into your calculator. We do the pi button and the pi button only. We do not do 3.14. Then, and we'll talk about the settings, we round it to 3 decimal places, not 2. That means on every pi problem, if they go to a decimal, some of them they'll leave with pi, but if they go to a decimal, every single one of the book's answers is wrong for our purposes. Do not erase it and change your answer to match. Do not circle it with a red pen that it is correct. Leave it uncircled, even if it's an odd, and we will check it in class the next day. And if for some reason it's not on the key, it means I need to fix the key and get that one added. We just missed getting that written in and saved. So does that much make sense? Okay, grab your calculators and let's make sure we all have the correct settings on them. So you are going to first push this home button. So you're on this screen. Then we want settings, which is choice 5. You can scroll to it, but that kind of takes a while. It's faster if you just push the 5. And then it gives you these choices. And again, you can scroll down to 2 and then push enter, or you can just hit the 2. And here are your settings. It's the top one that needs to be float, not float 3, not float 6. If it does not say float, if it has a number after it, push the arrow button and scroll all the way back up to the top and select enter for that. Should say degree there. Then, depending on your operating system and how recently it has or hasn't been updated, if you have a make default, click that. If you don't have that and it has an OK or save, click that. And then you should see a whole bunch of decimals when you do a problem, and we'll do one here in a moment, and you can practice entering it. Make sure you see all the same decimals that mine will show. Any questions on that? Everybody feel okay with that? When we start doing things on a graph, there's another place we have to go to fix the settings on those, but this should do pretty much everything else. All right, let's do two examples. So this one tells us that the radius is 10. And we want the arc length. Is that fraction times circumference or fraction times area? Everybody. Fraction times circumference. So we're going to start with a specific blank formula. We haven't plugged anything in yet. Arc length is x over 360. And then I can put in either pi d or 2 pi r. But which one do they give me? So it's going to make the most sense for me to do times 2 pi r. Then I plug in numbers I know. How many degrees out of 360 am I looking for? So my fraction is 45 over 360 times 2 times pi, and my radius is 10. I need to simplify everything except for the pi. So if I don't do that part with a calculator, I would need to look at it and say, well, what can cancel? Oh, a 10 will get rid of that 0 and make it just a 36. And then, oh, wait a minute, 45 and 36 are both divisible by 9, right? So if I divide the top by 9, I have a 5, and the bottom by a 9, and I have a 4. But then I also have, this would also be in the numerator. So I have a 2 over 4, which is the same as 1/2. So that needs to be simplified to 5/2 times pi. Got to have it like that in your answer, simplified all the way, reduced as much as that 5/2 can be. And these units are centimeters. You may either write that as 5/2 times pi or 5 pi over 2. Now we want to enter that on the calculator. So if we do control divided by, whoops, let me get back to, I didn't click the OK on that. Let me get back to a calculator page. Now I can do control divided by, and it gives me that nice horizontal fraction bar, makes it easy for me to get the numerator parts in the numerator and denominator in the denominator. And I enter 5 pi. I don't have to do 5 times pi. I can just do 5 pi and then tell it out of all of these, enter, yes, I want the pi. Use my down arrow on the touchpad and then put a 2 down there. This has a pi in it, so it's going to give me a decimal answer. If it didn't have a pi and I knew I wanted a decimal, I'd enter a decimal after one of the numbers, 2 point, and that'll force a decimal answer. But I don't have to do that since pi's in there. I just push enter, and I have all of these numbers. So did everybody get your settings right so that you're seeing all of those digits in there? Now we round to 3 places. So 7.853, look at the 9, and it needs to bump that 3 up to a 4. So 7.854. And we have both of those answers, and we circle with a pencil. If it's an odd, we look in the back of the book. If they have 5 pi over 2, we can circle that with our red pen. If not, if all they have is a decimal, we say, oh, it's close to that. I'm probably right, but I wait to check it till tomorrow in class. Yes, Alex? Let's see. That is another thing in settings. Let me do that in just a minute for you when I'm not recording. Okay, let's now do same picture, but let's find the area of the sector. So we start with area is x over 360 pi r squared. The x is still 45. And the radius is still 10. And I could simplify this manually like I did to get to the 5/2 on the previous problem. However, if it's either homework or a calculator part of a test, and you aren't real comfortable with simplifying fractions by yourself, let me show you how to have the calculator give you the reduced answer. I won't enter the pi yet. I will enter everything else. So let me get my calculator back up here and move it enough that I can maybe see what I need to enter. Okay, I'm going to do control divided by again. And I hit the wrong thing there, so let me delete that. Control divided by, there we go. And I'm going to do the 45s in the numerator, skip the pi for now, and the 10 squared. Oops, I don't think it got the times in there, so I'm going to go back and fix that. Times, that's looking better, 10 squared. Notice how I was hitting the delete if I needed to go back and get rid of something that didn't look right when I looked at my screen. Then I'm going to go down to the denominator and put the 360 in there. So I still need to worry about pi. This is everything but the pi. Now I can push enter and get back where I can see its answer, 25 over 2, but still times the pi. So if I didn't want to do it by hand, I could say that the fraction part becomes 25 over 2, still times the pi. Then I can enter that on the calculator by just doing times, and it says take that answer, times pi, and hit enter for the pi button, and enter to get my decimal. Are we coming up with that on your screens? Now I need to take the 39.269, but then I've got a 9, so I need to round that 9 up. When I have a 9, I think it's easier to think of it as 39.269. And I need to round that 69 up to a 70, so 39.270. Do write the 0 to show I'm accurate to 3 places, not just to the nearest hundredth. I'm accurate to the nearest thousandth. We're still dealing with centimeters, but is it regular centimeters for area? It's going to be centimeters squared, so I get those labeled in, and I circle both of those. If it's an even one, only with my pencil. If it's an odd, I look and see what's in the back of the book, but the decimal for sure is going to be different. So any other questions from anybody there? We are actually stopping here. That's only the first part of lesson B. We'll do the rest of it tomorrow. We did the 2-dimensional things today with circumference and area, perimeter. Tomorrow we'll do 3D stuff with volume and surface area. So let me give you your homework sets, and the whole assignment will be due on Friday. But tonight I want you to do as much as you can and come ready to ask questions tomorrow before, and then we'll finish the new material, and then you'll be able to finish that. Some of you may do the whole thing because you remember your volume and surface area, but then you'll want to check if there's anything I say about format and showing your work on it.